Hello everybody. Today we are going to study about number systems. In this tutorial we are going to deal basically about four number systems. They are decimal, binary, octal and hexadecimal. Decimal number is a group of numbers which are represented by the base 10. So any number xyz represented by the base 10 represents it is a decimal number. Decimal number includes the numbers between 0 and 9, that are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Binary numbers, as you all know, include only two of them, that are 0 and 1. Representation of the binary numbers include when the base is 2, so anything in the form x, y, z to the base 2 is referred as a binary number. Moving on to the octal system. The octal system consists of 8 numbers ranging from 0 to 7. Any octal number is represented by xyz to the base 8. xyz are any numbers between 0 and 7 in the case of octal system. In hexadecimal numbers, there are a total of 16 numbers present in the system. These are numbers from 0 to 9, and numbers from 10 to 15 are represented as A, B, C, D, E and F. So these 10 and these 6 they represent the 16 hexadecimal numbers, and the hexadecimal number is represented by the base 16. Now let's learn about conversion of one number system to another. Let us take a number 327. This is a decimal number and we want to convert it to the binary equivalent. So we want to convert a number from the base 10 to the base 2. So what we do is we write the number 327 and keep it dividing by 2. So when we divide 327 by 2, we get the quotient as 163 and the remainder as 1. We keep writing the remainder onto the right side. Once again we divide this by 2, we get 81 and again the remainder is 1. Divide by 2, we get 40, remainder 1, divide by 2, we get 20, remainder 0, divide by 2, 10, remainder 0, 2, 5, 0, 2, 2, 1, 2, 1, 0. We divide it by 2 till we get 1 on the quotient side, and once we get 1 on the quotient side, all we have to do is draw arrow from down towards the upside. So and we will write the numbers in this order. So the binary equivalent will be 1 0 1 0 0 1 1 1. So this is the binary equivalent of 327. So this is how you calculate the binary equivalent for a whole integer number. Now let's consider this example when we have fraction. So in the case of fraction, let me add this again on the next page. So let's consider 0.65625 to be converted into binary. What we do in this case is that we consider only the part after the decimal place, that's 0.65625, and we multiplied it by 2. So when we multiply this by 2, we get 1.3125, and we only consider the part before the decimal point. In this case it is 1, so we write 1 over here. Now in the next step, what we do is we neglect the 1 and only consider the part after the point once again. So we will consider 0.3125 and again multiply by 2, we get 0.6250. In this case the whole number part is 0, so we'll write 0. Once again we do this step and we repeat this step till we get 0.0000. If we are not getting the 0.0000 after many such steps, we just perform these steps like 8 to 9 times and leave it there. So returning to this problem, I'll again write 0.625 into 2, I get 1.25, 0.25 into 2, 0.5 into 2, we are getting 0.00 in this case. And so in this case we'll go in the reverse order, so we'll draw the arrow from up towards the downside, and so the equivalent of this number would be 0.10 101. So that's how you convert a decimal number into a binary number. So now let's move on from converting a binary number to a decimal number. Let's consider the same example. If you want to convert this number to decimal number, so what we will do is, this is the most significant bit and this is the least significant bit in case of fractions. So here is 10101, so we'll write the 1 as 1 into 2 raised to minus 1, as this is the 2 raised to minus 1, 2 raised to minus 2, 3, 4 and 5, plus 0 into 2 raised to minus 2, plus 1 into 2 raised to minus 3, plus 0 into 2 raised to minus 4. This gives 1 by 2 plus 1 by 3 plus 1 by 32. When we solve this, we get 0.65625. So in this way, a binary fraction is converted into a decimal fraction. Now if we consider a whole number, let's take the same example, 101000011. If you want to convert this into decimal, what we'll do is we'll write this as in the powers of 2. So this is the least significant bit and this is the most significant bit. So we'll start from 2 raised to power 0 and move in ascending order. So it will be like 1 into 2 raised to 0 plus 2 raised to 1 plus 1 raised to 2, 3, 4, 5, 6, 7, 8. So solving this, we get 327. So this is how we convert a binary number into a decimal number. So yeah. Moving on, we consider the conversion of a decimal number, XYZ decimal number, to an octal number. So let's consider the example of 247, a decimal number, and we want to convert it into octal. So what we do is we take 247 and keep it dividing by 8. So we get 30 and the remainder is 7. Once again we divide by 8, we get 3 and the remainder is 6. Once again we show the arrow from down towards the upside, and so the equivalent would be 367. Reversing this, that's the conversion of an octal number to a decimal number is exactly the same. Instead of 2, we just take 8. So here, if we want to convert 367 to decimal, then we'll take the powers of 8. That means 7 into 8 raised to 0 plus 6 into 8, 1 plus 3 into 8 square. Solving this, we will again get 247. Okay, so let's move on to the conversion of a decimal number from a decimal number to a hexadecimal number. So let's say, for example, if our decimal number is 2095.0937 and this has to be converted into an hexadecimal number. So what we'll do is, for the real part of this number, we'll consider first the real part of this number and keep it dividing by 16. So when we divide this number by 16, we get the quotient as 130 and the remainder as 15. Once again divide by 16 and we get quotient as 8 and the remainder as 2. Once again we write from bottom to the top, so we get the equivalent as 8, 2 and 15. And in the hexadecimal system, 15 is represented by F. So the equivalent number in the hexadecimal system becomes 8 to F. So now let's calculate the fractional part of this number. The fractional part of this number is 0.0937. So what we'll do is we multiply this number by 16. So we get 1.4992. We again write the real part of this number on one side, that is 1. We take 0.4992 and multiply it by 16, and we get 7.9872. We get 7, and we keep doing this thing for about 6 to 7 more times and keep writing the real part again. So again we'll continue these steps, so we'll get 0.17 something. So the equivalent number converted in the hexadecimal system will be given as 8 to f.17 and the rest calculated. So now let's move on to the conversion of a binary number to an octal number. So if our number is given in the binary form, for example, let's take 0, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, point 0, 1, 1, 1, 1, 1. And this is a binary number, and this has to be converted into an octal number. So what we'll do is we'll divide a binary number into groups of 3, and we start the grouping from the right side. So we'll make groups of 3. So this 3, 3, 3 and 3. In the fractional case, we'll group from the left to right. So in this case 3 and 3. If the numbers are not in the group of 3, we'll add extra zeros to the left, and so the groups have become groups of 3. And in the fractional case, if they are not a multiple of 3, then we'll add zeros to the right of the number. So after the grouping, all we have to do is convert these numbers into its decimal equivalents. So this becomes 137.37. So this is the representation in the octal system. So yeah, we have converted the binary number into the octal number. So now let's move on to the conversion of binary number into an hexadecimal number. So let's consider the same number 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So if we have to convert this number into an hexadecimal number, instead of grouping the numbers into groups of 3, we'll group in the groups of 4. So we'll group in the groups of 4. So this 4, this 4, this 4, and we see this 1 0 is left out. So what we do is we add 3 zeros to the left, so that this becomes a group of 4. Similarly, we have 4 and add 2 zeros to the right, so this becomes a group of 4. Once again, we'll just calculate the decimal equivalent of these numbers, and so that will be the hexadecimal equivalent of the binary number. So now moving to the last part, what if we have the converted number with us and we have to find the base of the number? For example, let's take this number as 361. It's a decimal number, and it's given that it is 551, and after the conversion, and we have to find the base of this number. So how to find the base? So now what we do is we write we will write an equation just like we have been doing for octal and octal and binary, etc. So we'll write 361 is equal to, let's take the base as b, so it will be b plus 5b plus 5 b square. Sorry, it will be 1 plus 5b plus 5b square. So solving this equation, we'll get the value of b as 8. So yeah, this will be an octal number. So yeah, that's about this video. I hope to see you in my next video. Peace.